Okay, so we have a rational inequality, and we're going to give it a go to try to solve this using a sign chart. Now, the first thing is that we want to make sure that one side of our inequality is equal to 0. And then the other side of the inequality, we want to make sure that it is written as one fraction. One single fraction. Okay. All right. And once we have it in that form, which this one already is, then we want to make sure that we figure out what our critical values are. So for our critical values, we are looking for, this is for our sign chart, we want to find those critical values. We are looking for anything that will make our function, this function, equal to 0. So we're looking for the, when is the numerator going to be 0? So we look at when is 2x plus 5 going to equal 0, which is at x equals negative 5/2. And then also where our denominator is going to equal 0. In other words, where our rational function is undefined. So when is x minus 1 equal to 0? It's when x is equal to 1. Now, our critical values then are going to be at negative 5/2 and at 1. So when we take a look at making our sign chart, we have negative 5/2 or negative 2.5 and 1, and we do just like we did with our polynomial inequalities, and we're going to do some test points in each of the intervals that we have. So we've got an interval here, here, and here, and we're looking to see what's happening. Is our function, is that rational function above the x-axis or below the x-axis? So since we are starting out with the negative 5/2, let's go to the right of it, and we'll test a point that is to the left of it, and we'll test a point that is left of negative 2.5. So let's just type in, or try, negative 3 as our test point. Now again, we don't actually have to evaluate the number, the actual number, when we put negative 3 into our entire function, but we'll take a look at what it would look like. It would be 2 times negative 3 plus 5 divided by negative 3 minus 1. And that would give us a negative 6 plus 5, negative 6 plus 5 over negative 4. Let's get rid of this here. Okay. And then we'll end up with a negative 1 over negative 4, which is a positive 1/4. Now, what that means, since that's a positive 1/4, for negative 3, then in that particular area of the graph, anywhere that is left of the negative 5/2, we will end up with a positive value. Now, let's test a point between the negative 5/2 and the 1. So let's pick 0. That'll be an easy one to do. So when we pick 0, we get 2 times 0 over, or plus 5 rather, over 0 minus 1, which gives us 5 over negative 1. 5 over a negative 1, which gives us a negative value, which means that all of the values that are between negative 5/2 and 1 are going to end up being negative. And then let's test a point for when we are to the right of 1. So let's test the point of 2. So we do 2 times 2 plus 5 over 2 minus 1, which would give us 4 plus 5, which is 9, over 2 minus 1, which is 1, which is 9, and that is a positive. And so, in this case, we are looking for when is the function value is going to be less than or equal to 0. So, less than or equal to 0. So we're looking for the ones that are going to be negative, which is going to be these guys will be negative. That's going to be the only ones in the intervals, the 3 intervals that we checked, that are going to give us negative values. And then let's take a look, though it said it could also equal 0. And so when is it going to actually equal 0? Well, that's when your numerator is 0. And so when our x value is -5/2, that will also make it equal to 0. So this particular point will work, and then all of the points that are between -5/2 and 1 will work as well. So for our final solution then, we would write that we are going from bracket -5/2 up to 1, but not including 1. Why can't we include 1? Well, 1's not going to work whether it can equal 0 or not equal 0, because the 1 is going to make that rational expression undefined, and so we can't use 1 either way. So there is our final solution, and that's what we do using a sign chart. Now, if we take a quick look at what this graph might look like, we can use our asymptotes to give us a hint here. So for a vertical asymptote, we would be at x equals 1. So we'll have kind of an asymptote here. And then for a horizontal asymptote, we'll be at 2 over 1, which would be, let's say, somewhere up here. And then if we pick a point, in this case, to figure out where exactly will our x-intercepts and our y-intercepts will be. For our y-intercepts, if we put 0 in for x, then we would end up with a y-intercept equal to -5. So we'd be down here somewhere at -5. And then that's going to indicate, based on our asymptotes, that our graph is going to look something like curving down. But we should also then find out where our x-intercept is going to be. Our x-intercept is going to be when y is 0. Well, we already found that as far as looking at our critical values. So that ends up being -5/2. And so if we look at the at -5/2, that's -2.5. So we're going to be somewhere, let's say, around here. And we'll have a graph then that is doing something like that in that branch, and then the other one is going to be up here. So now when we take a look at where is that function that we've graphed, where is that function going to be less than or equal to 0, it's going to be in all of these values, which gives us from the -5/2 to 1 in our x interval. So that will verify our solution. Okay, so that's the first example.